Hello, I will be showing how we can use the entity graph to conduct an investigation and identify related activity within Taegis. I have identified this XMRig minor activity alert and created an investigation based off of it. Now I'm going to be using the entity graph to fully investigate this alert and identify any activity that is related to this. The first thing I'm going to do is open up the alert itself that I've added to my investigation and investigate the key details to determine whether or not this activity is a true positive or not. To start with, first I am going to scroll down to the process data and try to identify if the activity seen actually matches malicious activity. Reading the description of the alert, it says a process event associated with the open source GPU CPU miner XMRig has been identified. This activity may indicate that the host has been compromised. One of the things here is we can actually see some examples of what that activity might be. We can see references to an XMRig file here. And if we scroll down to the process activity, we see indeed that the file that was executed matches that XMRig description. So now we can see that inspecting this command line, we can see the user tom.wall use bits admin to download what appears to be an XMRig binary. Now that we know that this user tom.wall has done some suspicious activity, we can use the entity graph to identify any other suspicious actions this user may have taken. To access the entity graph, we are going to go back to our investigation and then select the entity graph button on the top right of our screen. When we click that button, that brings us to the entity graph. What the entity graph does is it'll map the relations between all of the observed entities from the alerts and events that we have added to the investigation so far. So not only does it graph what has already been added to this investigation, it can identify additional events related to the entities that we've already added. So let's say, for an example here, we know that the user responsible for you issuing the bits admin command was this tom.wall user. We can click on that user to identify any other related entities related to this user. This will give us a good example of any other alerts or events that could potentially be related to the activity we've seen. So when we click that pivot, it identified several other alerts all related to this tom.user within the 15-minute time frame that we have selected here. So here we see additional alerts related to XMRig or crypto miner activity. We also see an alert for a renamed Microsoft HTML application creating a Windows scripting host automation. This could give us an example of other activities that this tom.wall user attempted to take during this compromise. Opening up this alert, reading the description, we see a process event associated with the renamed Windows Microsoft HTML application utility, creating a Windows scripting host automation object was identified. This may indicate that an adversary is attempting to execute malicious content under the guise of a benign binary. This could mean that essentially this user is attempting to execute additional content on this host and describe it hide it and pretend to operate as like a legitimate binary. So looking at the actual process tree here, we see that this tom.wall user was using command prompt to create a scheduled task on this host, naming it Microsoft Office. We see here that they actually gave the task name here a typo, and it says instead of saying Microsoft Office, it says Microsoft Officer with this R at the end. Looking at like badly named or unusually named tasks could be an example of an adversary attempting to create a persistence mechanism on the host. So we see that this scheduled task is essentially executing that xmrig binary that we saw was downloaded using that bits admin command. So this shows how the actual actor would have ensured that xmrig binary they downloaded using bits admin would execute on the host even after the host went through a reboot of. So now that we were able to identify this as a legitimate persistence mechanism, it shows a good use case of using the entity graph to identify additionally related activity here. We see further alerts related to XMRig activity and creating a scheduled task on this host. So the entity graph was able to successfully identify additional activity related to this user time wall. We are actually going to add these alerts to our investigation by clicking the Add to Investigation button. And we can clearly see how it's able to then add even more details to our graph here. Now, if you remember, the entity that we have selected here is this time wall. So this is able to graph all of the activity related to this time wall user. We can see that they executed things on this SRO.KIO4 host. We can see that user then executed xmrig binary, a bits admin binary, and even some additional nodes such as command prompt. And then we can see this command prompt execution is also related to executions of scheduled tasks. So this shows the relations of some of those different entities that we were able to identify just based off of pivoting from the entity graph alone. Additionally, if we go back to exploring, we might identify any other events that are related to this activity as well. So we started this investigation off of pivoting off of the user. Next, we're going to attempt to pivot off of the host to determine if there's any other alerts on the host itself that potentially were not related to the user alone. To do that, we're going to click on this host name entity. And then just like before, we're going to select explore related entities. So this is going to show us any other entities that are related to this activity within that 15-minute time frame. So here we can see all of the other alerts that we've seen. And then we also see one additional alert for CPU, GPU minor network traffic. Opening this alert, we can see that this activity is fired based on the presence of this Monero hash domain, which is a domain that we know to be associated with CPU and GPU minor traffic. Once again, this shows the power of the entity graph in being able to identify related activity or alerts to be able to influence our investigations. So once again, we're going to select that alert and hit add to our investigation. And then we see that that activity is now added to our graph. We now can see, based off of this node, we can see that this username Tom Wall executed activity on this host. And one of the things related to this was a DNS request to Monero hash. Again, this shows the power of using the entity graph to be able to identify related activity to enhance our investigations. Thank you for your time and have a good day.